Hello and welcome. This is Dr. S. N. Mehboob, working at SR University Warangal as an assistant professor in the Department of Mathematics, School of CS and AI. This lecture is continuation of previous lecture. In previous lecture, we have seen the basics of sample space, events, random experiments, and their outcomes. We have seen how to find sample spaces for simple experiments like coins, dice, and cards. And we have seen how to use probability formula and solve basic problems. By the end of this session, you will be able to explain the difference between events with replacement and events without replacement. You will be able to apply addition and complement rules to solve probability problems. So let's begin. I recall some definitions from previous lecture. So what is probability? What is probability? Probability measures the likelihood of an event occurring, expressed as a value between 0 and 1. Value between 0 and 1. So probability of an event 0 means occurrence 0% chance of occurrence, and probability of an event 1 is 100% chance of occurrence. So in last lecture, we discussed types of events. Probability formula. Probability of an event is equal to number of favorable outcomes divided by total outcomes. So what is the meaning of replacement and without replacement events? So with replacement means after an item is selected, it is put back into the collection before the next selection. In this process, the total number of items stays the same. So here the number remains unchanged. And without replacement means after an item is selected, it is not put back into the collection. In this process, the total number of items decreases after each selection. Let us suppose that one box there are 5 black balls and 4 red balls. We are selecting one black ball. We are selecting one black ball, and we are not putting back this black ball into the box. Then the remaining number, then the remaining 4 balls. 4 balls. So total number changes 5 to 4. 5 to 4. 4 black balls and 4 red balls. And if you put it back into the collection, into box, then the number will always be same. Then the number will be 5. This is the concept of with replacement and without replacement. So before solving the problem based on cards, let me quickly give you brief overview of cards. So in deck of playing cards, total 52 cards, total 52 cards, 26 black cards, 26 black cards and 26 red cards. In 26 black cards, there are two types of cards. 26 black cards, there are two types: spades, 13 spades and 13 clubs. And in 26 red cards, there are two types: 13 diamond cards and 13 heart cards. And total face cards, total 12 face cards. Face cards means uh, Jack, Queen and King. So let us solving problem based on card. So in this problem, your two cards are randomly drawn from a deck of 52 cards without replacement. One thing is given here, one point here: without replacement. What is the probability that one card is a heart and the other is a diamond. Now come to the solution of this problem. Total number of cards, total number of cards 52 cards. We need to find probability of drawing heart and diamond. So total number of heart cards 13 and total number of diamond cards 13. So there are two cases. There are two cases for selecting heart and diamond. So first we can select heart and then diamond. And second case, first we can select diamond and then heart. There are two cases for selecting heart and diamond. So consider first case, selecting first heart and then diamond. So first draw a heart, then diamond. So probability of selecting heart card. So first card is heart. So 13 total number of favorable outcomes. So total 13 heart cards. So 13 by 52. So probability is 1 by 4. And then second, we are selecting diamond. We are selecting diamond. We have already drawn heart, and one point is given in problem without replacement. Without replacement is given. So we are not putting back. We are not putting this heart card into deck of cards. So of course, so total number of cards decreases. So 52 to 51. So total number of diamond cards 13 and total number of cards decreases to 51. So 13 by 51. 13 by 51 is the probability of selecting diamond card. So probability of selecting heart first and diamond second. So here we are multiplying. Here we are multiplying probabilities because selecting one selected card cannot be both, means heart and diamond. So both events are independent. When events are independent, so we multiply probabilities. We take product of probabilities in the case of and and in the case of or we add. So 1 by 4 into 13 by 51. So which is 13 by 204. This is probability of this is probability of selecting heart and diamond. Second case, probability first card, in second case drawing first diamond and then heart. So we are selecting heart, we are selecting diamond first. So total number of diamond cards 13 diamond cards and total number of cards 52. So probability of drawing hard diamond first. So 13 by 52, which is 1 by 4. And after selecting we are not putting back, we are not putting card into the collection because it is given in problem without replacement. So total number of cards decreases 52 to 51. So heart probability of heart selecting in second selection, we are selecting heart card. So total number of heart 13. So 13 by 51. So similar to first case here, both are independent. Both are independent because single card cannot be both diamond and heart. So both are independent events. So probability of diamond first and heart second is 1 by 4. 1 by 4 into 13 by 51. So which is equal to 13 by 204. So since these two cases, case first and case second, both are independent cases. Both are independent cases. So in other words, we can say both are independent events. Both are mutually exclusive because In first case we are drawing heart card, and in second case we are drawing diamond card. So single draw cannot be both heart and diamond. So first card cannot be both heart and diamond. So it means both events are mutually exclusive. So probability, so we mutually exclusive, so probability. And here case, there are two cases, case 1 or case 2. So here we have word or. So both are, first case and second case, both are exclusive mutually exclusive, and here we have a word or. So we add probabilities. So 13 by 204 plus 13 by 204, which is equal to 13 by 102, which is equal to 13 by 102, which is the required probability, Now these are some rules. First two rules are important: addition rule and complement rule. So what is addition rule? So two events A and B, suppose that two events A and B, then the probability of A union B is probability of A plus probability of B minus probability of A intersection B. This is addition rule, and probability of A complement is 1 minus probability of A. So first, and if a third rule is, if A is a subset of B, then probability of A is less than or equal to probability of B. So first two rules are important that we are going to use in remaining problems. So now come to the set operations and event algebra. So A union B, suppose that A and B are two events. Suppose that A and B are two events, then A union B means event A or event B occurs, and A intersection B means event A and event B both occur. A complement means event A does not occur. A minus B means A occurs and B does not. So now come to the problem selecting balls. So here a bag contains 4 green balls, 6 black balls, 7 white balls. So a ball is drawn at random. A ball is drawn at random. What is the probability that the ball drawn is either green or black? Either green or black. So total number of balls, total total 4 plus 6 plus 7. So total is 4 plus 6 10 10 17 balls, total 17 balls. And number of green balls 4, and number of black balls 6, and white ball number of white balls 7. Let let A be the event. Let A be the event drawing green ball. Drawing green ball, selecting green ball, and B be the event selecting black ball. Selecting black ball. So probability of drawing green ball. So P of A, total number of green balls, total 4 green balls, so 4, and total number of balls 17. So 4 by 17 is the probability of selecting green ball, and probability of selecting black ball, probability of drawing black ball. So total 6 black balls, 6 by 17. This is probability of selecting black balls. and we can see A and B both are independent events, because a single ball cannot be both green and black. If we are selecting one ball, so one ball cannot be both green and black. So it means event A and event B both are independent events. So when events are independent and we have word or, so we add probabilities. So probability of A or means union A union B is 4 by 17 plus 6 by 17. 4 by 17 plus 6 by 17 is 10 by 17. 10 by 17 is the required probability. Now come to the next problem. So next problem is problem based on selecting card. So a card is drawn from a well shuffled pack of 52 cards. What is the probability? What is the probability that the card drawn is either spade or an ace? So total number of cards, total 52, total 52 cards, total number of spade cards, total spade cards, total 13, and total number of ace cards in deck of playing cards, total number of ace cards 4. So let us suppose that A be the event of drawing spade cards, drawing spade, and B be the event drawing ace cards, ace card. So A intersection B, one card is common. Card is common. Is ace of spade. Ace of spade. So A intersection B, in A intersection B, number of elements 1. So probability of A, total 13 spade. So 13 by 52, and probability of ace, probability of B. Here, because we have already taken B is the event drawing ace card. So P of B is 4 by 52, and P probability of A intersection B 1 by 52. So by addition rule, probability of drawing either spade or an ace. So P of A union B is P of A plus P of B minus P of A intersection B. So P of A is 13 by 52 plus P of B is 4 by 52 minus 1 by 52. So which is 16, which is 16. 13 plus 4 15, 13 plus 4 17, 17 minus 1 16. 16 by 54, 16 by 54 is 0.31. By simplifying we get 0.31. So 0.31 is the probability of selecting spade or an ace. Now come to the next problem. This is problem based on problem solving. There are two problems. So the probability that a student will solve problem A is 2 by 3, and the probability that he will not solve problem B is 5 by 9. If the probability that the student solves at least one problem is 4 by 5, so what is the probability that he will solve both problems? So here we need to find P of A intersection B. P of A intersection B. P of A is given. Probability of solving problem A is 2 by 3, and probability of not solving problem B is given. So it means P of BC is given. P of B complement, so 5 by 9. So P of B complement formula, we know 1 minus P of B. So P of B is 5 by 9, 1 minus P of B. So from here P of B is equal to 1 minus 5 by 3. 1 minus 5 by 3. 1 minus 5 by 3. Sorry, here 5 by 9. This is 5 by 9. 5 by 9. So 1 minus 5 by 9. 1 minus 5 by 9, which is so probability of B is 9 minus 5, 4 by 9. This is probability of solving problem B. So probability of solving, we have probability of solving problem A, probability of solving problem B, and probability of solving at least one problem. At least one problem. So A union B is also given. So 4 by 5. So using addition rule. So by addition rule, here P of addition rule is P of A union B is equal to P of A plus P of B minus P of A intersection B. So we have P of A union B value, P of A value, and P of B. So substituting all values, so P of A union B 4 by 5, and P of A value, P of A is 2 by 3, plus P of B value, P of B is 4 by 9, minus minus P of A intersection B. So from this equation, P of A intersection B is equal to 2 by 3 plus 4 by 9 minus 4 by 5. Minus 4 by 5. So by simplifying, we get 42 by 135, which is equal to 0.31. So this is the probability of solving both problems, problem A and problem B. So now come to the next problem. In this problem, it is given 100 students appeared for two examinations, 60 students passed first exam, and 40 students passed second exam. So 30 students passed both exams. Find the probability randomly randomly selected student passed in at least one examination, and second task passed in exactly one examination and failed in both examinations. So A let A be the event passing first exam, passing first exam, and B be the event passing second exam. And given that a number of elements in A, total 60 students, number of elements in A, and number of elements in B, 40 students, and number of A intersection B, it is given. So 30 students passed both exams. So 30 students. So passed in at least one examination. In one examination means A or B. So A or B means A union B. So by using addition rule, P of A union B is equal to P of A plus probability of A plus probability of B minus probability of A intersection B. So probability of A, total number of students 60 students, 60 divided by 100, plus probability of B, total 40 students, 40 by 100, minus in A intersection B 30, so 30 by 100, 30 by 100, so 60 plus 40, 100 minus 3, 30, 70, 70 by 100, so 0.7. So 0.7 is the probability of solving and probability of passing one examination. Second task is passed in exactly one examination. So at least one means we have to subtract probability of solving both examinations from each that is P of exactly one here, probability P of exactly one means probability of solving problem A minus solving both problems, probability of solving both problems, plus probability of solving problem B minus probability of solving both examinations, sorry, not problem, examination. So probability of A is 0.6, and probability of solving probability of passing both examinations 0.3. So 0.6 minus 0.3 plus probability of passing second exam, so 0.4 minus 0.3, so which is equal to 0.6 minus 0.3 is 0.3 plus 0.4 minus 0.3, 0.1, so which is equal to 0.4. So this is probability of solving exactly one. And third task is failed in both examination. Failed in both examination means we have to we have to take A union B complement, because A union B, probability of A union B, this is representing solving at least one. So if we take complement of this, so we get failed in both. This is pass, this is probability of passing at least one examination. So if you take complement, so complement is failed in both. Complement of this is failed in both, so which is 1 minus probability of A union B. So 1 minus probability of A union B, we have already calculated. A union B is 0.7, so 1 minus 0.7 is 0.3. So probability of failed in both examinations is 0.3. Now come to the last problem of this session. A computer software company is bidding for computer programs A and B. The probability of getting software A is 3 by 5. The probability of getting software B is 1 by 3. And the probability of getting both software A and B is 1 by 8. So task is to find the probability that the company will get at least one software. So probability of A, probability of software A is given. Getting the software A is given. So probability of getting the software A is 3 by 5, and the probability of getting the software B is 1 by 3, and the probability of getting the software A and B is 1 by 8. And task is to find what is the probability that a company will get at least one software. So at least one software means the probability of getting getting A or B. So it means probability of A or B. So by addition rule, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A is 3 by 5 plus probability of B is 1 by 3 and probability of A intersection B is 1 by 8. By simplifying we get 97 by 120. So 97 by 120 0.81. So the probability of getting at least one software A or B is 0.81. This is required answer. Thank you for watching.